Welcome. This is Annegret, and a warm welcome to my talk today about AsyncAPI and domain-driven design, a pretty couple. Hello, my name is Annegret and I'm the Chief Software Architect at Codecentric AG. I'm interested in domain-driven design, in API design, and obviously even in microservices, because everything in architecture depends on each other. And I'm really enjoy this talk today, and I hope you enjoy it as I when I prepared it. I belong to Codecentric. Codecentric is a German IT consultancy company located in Solingen with subsidiary in most of the large cities in Germany. I'm for myself from Munich. We code, but we try to coach our customers so that they afterwards, after our consultancy, are able to do the things they couldn't do without us before. First, I want to talk about domain-driven design. So let us see what does it mean in the process and what does it mean for events. So, and what you can see here, it's a plan for the strategic design part of domain-driven design. And before we do anything, we need some kind of business idea. And we need to write down that business idea using a so-called business canvas developed by Strategizer. I will show you an example later on in this talk. And inside of that business canvas, we collect some kind of business capabilities of what we want to implement. And how we can them implement by our own, or if we buy something, etc., we can prioritize using a water map along a certain evolution of a product from a genesis over a custom implementation of a product which needs to be applied, or even some kind of commodity. And when we have that, then we can see for the parts we want to do by ourselves in the genesis part, or even in the custom part, we need to gather business requirements. And those business requirements are collected along a domain storytelling. I will show you an example for it later on as well. And the next step then is some kind of a solution design, and we can approach this solution design using event storming. And we use a lot of terms inside of our business capabilities, inside of our domain stories and event storming, and we need to define them. And a really easygoing and nice to understood model is a so-called visual glossary. Also we define our terms using a visual glossary, and then we can do some kind of system architecture using the context map. And then we can define inside of the context map the data exchange we need for our system. And then we go deeper into the bounded context themselves and using some kind of technical design. Using the context map we had created before, we can define the construction and usage of our domain model, and we can define our repository as kind of API to the database. And then we can define the APIs. As we said, we have detected the necessary data exchange before, and then we can say, okay, here, that are the APIs we need. Might it be asynchronous APIs or might it be synchronous APIs? And we will extend our APIs by the aggregates we detected before using our event storming. How does it go? You will see during the talk. And we can then go deeper in the domain model using the schemas and define the schemas, define additional entities, and we can define the value objects which need to combined during the entities and the value objects inside of the aggregates. So what you can see here is a business plan canvas or business model canvas. We have here the key partners, we have key activities, we have key resources, we have key propositions, we have customer relationships, channels which are used to contact our customers, customer segments, and of course we need some kind of a cost structure and how we want to back up those costs with our revenues and our revenue streams. And the example I brought with me today is a small task management system for a freelancer, for example, who want to create and finish task and afterwards write an invoice on it. And what you can see, we have those capabilities, which have here that red ellipses around, to create and finish tasks for freelancers and craftsmen. And to see we have those are the key activities and the key customer segments. Obviously, we need some kind of key partners with small companies, and we want to do everything via mobile application and even integration to some kind of invoicing systems. So we found our business capabilities, and because we have only 2 of them, so it's easy to prioritize. We said, okay, that is the thing we want to do ourselves, and the invoicing part we can do as a commodity and integrate our system with invoicing or ERP systems. So what you see here is a diagram created during a workshop using domain storytelling. Domain storytelling is a methodology created by Stefan Hofer and Henning Schwendner. And it's a methodology where inside of a workshop, the business requirements are gathered in a visual form. And you can see here's a visual form using sentences with an actor. So here, for example, the freelancer with actions, 1 creates, 2 assigns, etc. And then with work items here, for example, the task. So let us go through it. The freelancer creates a task which is stored in an inbox. Then the freelancer assigns the task to himself, and third, he works on it. Then he or even she set it to done, and when the task is done, we can create a follow-up task which again is stored in the invoice. And when a couple of tasks are done, then an invoice can be created and the task is done. And what you can see here is those things are created together with the business experts in workshop, and you can see that it's really easy going and you really can understand it even afterwards quite easily. The next step then would be an event storming. Event storming was introduced by Alberto Brandolini, and it's a kind of a brainstorming technique combined with technical knowledge. It's really great. And in the first step, you collect events in the storming phase, and every workshop attendee collects their own events. And in the second step, in the quality consolidation or quality step, the events are consolidated so that the steps are not doubled, etc. And common words are used, and you can see it here that they are brought from in a sequence from the left, the first event, to the right, the last event. And in our small example is I have task created, task assigned, task processed, task done, and that cycles can be repeated for the follow-up task, and then the tasks, when they are done, they can be invoiced. And the task itself needs to be enhanced by certain information, and the information first is a command which triggers the according event. That might be create task for task created, assign task for task assigned, process task for task processed, finish task for task done, write invoice for task invoice. And then we need to define who will do it. It might be a human role, or it might be even a technical system. Here in our sample, it's always a human role, and I call that human role clerk, but it might be even freelancer or whatever. And then you see here more which information is needed for the according event, and that might be information which is changed during the event. That is a hint for an aggregate inside of a bounded context, or it might be a so-called read models that are data which are not changed inside of the event, but it's needed for the event. Also, for example, when I want to create a task which is stored in the inbox, I need the inbox information, as you can see here with a green sticky note. And for the task assigned, I need some kind of user information called here clerk on the green sticky note for task assigned. And the last step inside of an event storming then would be to determine the according bounded contexts. And here we have 4 bounded contexts indicated by the blue ellipses: task management, invoicing, user management, and inbox. And first I only have the event, so I can easily determine the bounded context, task management, and invoicing. But I don't have events for inbox and user management, but I can determine them quite easily because I know I need the clerk information, and I know I need the inbox information. And this information need to come from somewhere, either of their own bounded context task management, so I can answer that with no, I can get information about a clerk from task management. So I need, so I know I need in different bounded contexts like user management, and I need in different bounded contexts like inbox. And when we then have that event storming, then we can go. So, and the system architecture we can nicely create using a so-called context map, or even context flow, sometimes it's called. So we draw for each bounded context we had before in the event storming, we draw a rectangle. Then we copy the events we had before in the according rectangles. As you can see here, task created, task assigned, task processed, task done is copied into the task management. And then we can discuss which data exchanges are needed. So we want to store things inside of the inbox, or at least make them accessible inside of the inbox, so that I can access in the inbox my task I need to do. So that means task created needs to be propagated into the inbox, and we can do it asynchronously because I create the task and probably only the next day I want to access them and see what I need to do. So I create the task, and then I can propagate the task created event. And obviously when I have done a task, then I don't need them anymore inside of the inbox because they are already done. So that means the task done event can be propagated to the inbox as well. And I can do it both asynchronously, because I need the inbox only as an overview and I don't need them when I work on a specific task. And then I want to invoice the tasks, which means I want to have the task done as a list, or however, inside of my invoicing system. That means I need to propagate the task done event to the invoicing system. So the task done event appears 2 times, either in the inbox or in the invoicing system. And then we can even discuss which data are needed from user management. I need some kind of user data so that I can assign my task, but that needs to be done synchronously, because when I create a task or the task is created, then I need some kind of user information inside of my task management system. So it's difficult to do it asynchronously. Therefore, here it's a get user from the user management, a synchronous data exchange. The arrows here in our context map are always drawn in the data flow direction, not in the access direction. So sometimes it's a little bit difficult to think about, because the get call is from the task management to the user management, but the data flow from user management to task management. Sometimes it's a little bit difficult. The context map can be additionally used to define the synchronous APIs which are needed for some kind of user interfaces, here as a sample post task, put task. But because today we want to concentrate of events and asynchronous data exchanges, I don't want to discuss this in any more detail. But what we could see, we can define nicely the necessary events using the context map. So, but anyhow, we used meanwhile a lot of terms, task, inbox, etc. And those terms need to be defined quite carefully. And it's necessary to define them together with the business, because what we need to do in the end is to use an ubiquitous language from the business side up to the IT side, up to the database even. It doesn't mean that the ubiquitous language is ubiquitous over the whole world. That's not necessary. We can have, and what you can see even here, an ubiquitous language inside of a bounded context. And what you see here are 2 bounded contexts, task management and invoicing. And the visual glossary shows us that the task is coming from an inbox, has a description, a title, a due date, has a status with new, in progress, and done, and a freelancer is assigned to the task, but works even on the task, but can be even the creator, and the task has 1 assignee. And afterwards, when the task is invoiced, you see it below, you have the invoice, and the invoice has invoice items, and the invoice item could be a task. And that is definitely something which is really useful, which can be nicely discussed in workshop, but what can be even done when you in a discussion with your colleagues. I really can recommend it. It's come from Stefan Zörner and is described in his book about architecture documentation. So I told you a lot about domain-driven design and how it could work in such a synergetic blueprint. But let us a little bit go deeper. What does it mean for AsyncAPI? So how we can combine it, I come to it later. First, let us look a little bit more about AsyncAPI. And AsyncAPI, as you probably know, is a method to define and specify asynchronous communication in the same manner as OpenAPI can be used to define a RESTful API. And here you can see the specification is published on the AsyncAPI page, and there are a lot of useful tools and even some kind of samples. And please look into it, read a lot. It's really interesting and useful for you, I think, to read. And such an AsyncAPI is in so far even nicely, and you will come to it quite fast, because it feels like an open API. So it's not so different, and you have an AsyncAPI as you have it in an open API, an info block, and the info block has a title, has a version, has a description, has a contact, and the description is even done like in Markdown so that it can be used for showing in HTML pages quite nicely. So, and in the second step, you need to define the service. And the service are the matches progress in your system or event buses. Here in that small example, it should be a Kafka event bus. It might be others like RabbitMQ or so as well. There are a lot of those things are introduced. You don't even need it, probably. You can even write your own when you like it. But there are a lot of things which are already defined by the large providers like Kafka or RabbitMQ. Here in the sample, it's quite reduced, so you probably need more bindings. So I would bid you to look into the documentation, how you can define the bindings for the different message brokers. Then you need to define the operation in the service using the event bus. So the AsyncAPI is not written in the point of view of the event bus, or the message broker is written in the point of view of the service implementing the operations, producing or consuming the messages. And here you see we have here our task created operation and task done operation, which need to be implemented in our task management, bounded context or service. You will find all the samples I will show you today inside of GitHub, so I can say to you, please use GitHub and have a look into it. And here you see that we have defined a task created event, which needs to be produced, and the task done event, which needs to be produced. But we didn't have here in our example, because it's really small and really simple, we don't consume any events. And you remember in our context map, yeah, we have the task created and task done event, which need to be produced by task management, and then it is consumed by task invoicing, and it's produced by task management. So, and obviously we need to define which messages we want to transport over our event bus. And here we have two channels, the task create event channel and the task done event channel, which contains the according messages. The problem we have here is that we have two channels, yeah, for the produced or events to produce or to be consumed. It corresponds with the topics inside of Kafka. And you can define the channels in the same manner as you would define the topics inside of Kafka. So you can do it quite nicely. And the messages we defined before need a certain payload. And the payload usually contains a header and contains the data itself. The header here, as you can see here, is oriented at certain standards like cloud events. It might be different standards, but what you need inside of the header, you can see here most. You need some kind of a correlation ID. The correlation ID is used to find different messages along your business process which belong together. So you have first the source creates the first correlation ID and other messages which were created based on that source along a business process use the same correlation ID. Then, of course, you have a message ID. I created it here additional wise, even so Kafka will create its own message ID, but here I can use a message ID even so I wouldn't use Kafka, therefore I put it here in our header, so the header would work even for other systems where probably other message ID logics are used. And you see a source, and the source is then the producer of the according message. Might be an interesting information when you have large systems where the events are produced by different systems and different services, so it might be an interesting information. The payload itself, also besides the header, we need the task, and the task can nicely be defined based on the visual glossary we saw before. So we have the ID, we have the title, we have the due date. We said, okay, create and SC are probably not necessary. That needs to be defined, and we have the status, and the status then can be nicely described as a string and an enumerator. So when you see the visual glossary, you usually can write down quite nicely the according JSON format or even Afro format when you want Afro as a format. I used here in my sample, I used JSON just because it's easier to understand than other formats and for such a talk. But no one really wants to write YAML. I know for myself that I struggle sometimes with my YAML. Even I have a good IDE which supports me quite well. But anyhow, it's not really nice. Therefore, it might be a better idea to use some kind of artificial intelligence which can assist to write those YAML definitions for us. So let us see if it really works. And yeah, what I can see here. Yeah, it works. It really works. And what you can see here, with the prompt, create an AsyncAPI specification based on the following skeleton, the following visual glossary, and the context map. The visual glossary and the according context map we already saw and discussed. Additional wise, you need a skeleton to give the whole thing a better structure than the artificial intelligence would use by themselves. The sample I provided here is from Cloud-D. You even can find the according prompts and the skeleton YAML inside of the GitHub link I provided for you here. And you can use the whole thing for your own when you want. Try it out. I, for myself, found that Cloud-D creates better results than ChatGPT, but ChatGPT is not bad. It works fine. You can do it for yourself even with other LMMs. I would assume that for most, the results are fine. Necessary definitely is a skeleton. So you need to produce some kind of skeleton, especially when you have requirements according to the structure and according to data bindings, etc. So you see here the event lifecycle was created based on the context map with task created, task assigned, task processed, task completed. It's a little bit too much, but I, for myself, to delete something out of a skeleton I get, it's better than to forget something. And so far, it's fine for me. The statuses were nicely coupled in status transition, as you can see here, with an enumerator, as you would do it. You have the task with certain properties based on the visual glossary, and you have a message structure which is consistent based on all things because we provided a certain skeleton. You can see all the things even here in GitHub with the cloudy answer. Have a look into it, it's quite interesting. So I said, yeah, probably it's a little bit too much. Yeah, we would need task created and task done, and it's even here called task completed. Okay, fine by me. What is not so fine definitely is that we have a lot of things in the task created payload, for example, where the description is missing and the examples are missing. And it's important to provide it for someone who doesn't know what you discussed before, that you provide a certain description for each object and each property and certain consistent examples so that your API definition can be understood. That is valid for OpenAPI definition as well as for AsyncAPI definitions. So here you need to work a little bit on the definition, but what is created by the artificial intelligence is enormous, and it's really really useful to use it and to use the LMMs as a good assistant for you when you program certain things. Let me conclude my talk. As you could see, and I think the thesis is really true. AsyncAPI and DDD are really pretty couple. I can use AsyncAPI nicely to specify my asynchronous events in an easy manner as for REST API and using OpenAPI. The whole domain-driven design process with domain storytelling, with event storming, with context mapping and visual glossary supports nicely and really good the formulation of events. The payload itself can be defined using the visual glossary. The events I need are defined by the event storming and the context mapping I created in my workshop together with the business guys. And the specification itself gets its structure by a predefined skeleton. And because I can do all those things when I use LMS using workshops together with the business guys, I'm sure that I have an event API, an AsyncAPI definition, which supports the business needed. I don't need to do it in my ivory tower. I can do it together in a workshop with the business guys. And the business guys are really happy to see that their requirements are mirrored in the code. Yeah, also when you see that AsyncAPI definition is code. It's really nice. I did a lot of workshops with business guys together with IT specialists, and it's great to see when they are so happy to see that what they want from the system is reflected inside an AsyncAPI definition. And use LMMs to assist you so that you can have the time to think and less time to write. Thank you very much. It was really nice talk with you here today. I hope there are a lot of questions afterwards so that we can have nice things together. You find me on GitHub and LinkedIn, so contact me when you have further questions and even contact me via my email address. Thank you very much.